Okay, so here we go. Like I said, 3 equations we're going to be solving. Now, this is day 1. We're going to do a little bit more advanced equations, okay, tomorrow. A little more trickier ones. Not trickier, just a little bit more work involved. Okay? We'll start out basic, though. And again, typical directions, right? Solve for x. Nothing surprising there. All right, and here is our equation. 3 over x plus 1 equals 9 over 4x plus 5. Okay? There's our equation. All right, you see why we call it a rational equation, right? Because we have a rational expression here, 3 over x plus 1. You can think of it as a fraction, right? And we have a rational expression here, 9 over 4x plus 5, and they are equal. There's the equation part, right? And we want to solve for x, right? Typically when we solve for x, we solve an equation, we want to get the x by itself, okay? Right now, we have a problem because our x's are in the denominators here. We got to get those x's out of the denominator, okay? Now, you have solved equations like this before. This is not new to you. In fact, I know for a fact in geometry, you've solved equations like this before. When you have a fraction equal to a fraction like this, what's a technique we can use to solve this equation? Now subtract. Cross multiply. It's a ratio equal to a ratio. This is a proportion. So we're going to cross multiply here. 4x plus 5 times the 3. I'm going to write this out explicitly here. You guys will probably skip this step when you do it on your own. 9 times x plus 1, so 9 times x plus 1 there. But I'm writing it out explicitly here because, well, it's notes, right? And it's going to be good to see what's really going on here. But once you're more comfortable, then you can start skipping that step. The point is that this 3 not only multiplies with 4x, right? The 3 multiplies with the 4x, it also multiplies with the 5. So the 3 distributes to the 4x and the 5. The 9 distributes to the x and the 1 there. So we get 12x plus 15 equals 9x plus 9. And now we are at an equation that you guys have known how to solve for at least a year or 2, maybe even 3 or 4, okay, depending on when you first took algebra. Okay? How should we go about solving this from here? What do I do now?
Subtract.
Yeah, subtract. I'm going to subtract 9x from both sides here to get the x's together first. Okay, so we'll have 3x plus 15 equals 9. And then subtract 15 on both sides. We'll get 3x equals negative 6. And then divide everything by 3. You got it. Okay. X equals negative 2. Now, you must check your answer in the original equation here. Okay, now I know back when you were first taught how to solve equations, your teacher was like, now class, when you solve an equation, you should always put your answer in and check to make sure that it's right. And you maybe did it for like 1 or 2, and you're like, that's too much. And then you stop doing it, okay? Well, you can't not do it now. You have to check it because there are situations where this x value will not work. It will not make the equation true. Okay? How is that good? How can we tell that really quickly? Basically, if you plug negative 2 in and you get undefined, that means you get divide by 0. That means that answer does not work. Okay? So if I plug negative 2 in here, negative 2 plus 1, is that going to give me 0 in my denominator here? Negative 2 plus 1, does that give me 0 in my denominator? No. So we're good there. And how about 4 times negative 2, negative 8, plus 5, negative 3? That's not 0 either, so negative 2 works. We're okay with that one. Okay, it doesn't make us undefined. All right, questions on that one?
So if we get from x, if it equals 0, then it's
when you plug in that solution that you get, if you get a 0 in the denominator as a result, right? If you were to plug that back in to check it and you get 0 in the denominator, you know that is not a solution. You throw it out. Okay, we'll see an example of that before the end of these notes here. All right. Second example. Second verse, same as the first. Well, pretty close. Okay. All right, again, rational expression equal to a rational expression, right? Fraction equal to fraction. This is a proportion here. Okay, one fraction equals one fraction. What's the technique we're going to use to solve this? We have a fraction equal to fraction. Yeah, cross multiply. like that. Okay, so 1 times 11x is 11x. 1 times 8 is going to give us 8. So we get 11x plus 8 equals, and then the x is going to distribute. So x times 2x is going to be what? 2x squared. And then x times 5, 5x. Very good. Uh-oh, we have x squared and x is in here. That means this thing is quadratic. In order to solve a quadratic equation, we want this to be equal to what? 0. So we got to subtract everything over so it's equal to 0. So I'm going to subtract 11x from both sides. I'm going to subtract 8 from both sides. I'll now have 0 here, and I'll have 2x squared. Let's see, 5 take away 11 is negative 6x, and then minus 8.
Wait. You brought it over a different way than I.
You subtracted 2x squared over? I don't like doing that because I don't like having a negative lead coefficient. So you can do it your way. That's fine. Just multiply both sides by -1, for example. That'll fix it. But okay. Now how do we continue to solve here? What are some options? Now we have our quadratic equation, right? It's equal to 0. What are some options we could use here? Factor it. What's another option we have? Quadratic formula. Yeah, if you're a masochist, right, you like pain. Quadratic formula. All right, and then number 3, you could graph it and see where it crosses the x-axis, right? Okay, so we'll factor this because I think it factors.
Do people really think the formula is that difficult? I find it the easiest.
I think it's probably more work than like the
There's so much to run.
factoring, I guess. I hear what you're saying though. Yep.
I feel like it's the easiest to solve.
Well, there you go. What can we take out? What can we factor out here, GCF wise? A 2. Okay, now we're going to factor this quadratic. We're looking for 2 numbers that multiply to -4 and add to -3. Yep, -4, +1. Okay, there's the factor, and it's equal to 0. Okay, now that it's factored, what do we do with each factor? Set them equal to what?
It was there.
0, yeah, exactly. Zero product property, right? X minus 4 is going to equal 0. X plus 1 equals 0, okay? We're going to add 4 to both sides. We get x equals 4 as an answer. We'll subtract 1 from both sides. You get x equals -1. Okay?
What do you do with the 2 that's in the answer?
Will 2 ever equal 0? So then you don't have to worry about it. You can set it equal to 0 if you want to, Teresa, but we know it's not going to work, so you can just kind of forget about it. As far as finding zeros. Okay. Good. All right, we got to check them. Plug 4 back in. 2 times 4, 8 plus 5, that's not 0. 11 times 4, 44 plus 8, that's not 0. Let's plug in -1. -1 times 2 is -2 plus 5 is going to be 3, not 0. -1 times 11 is -11 plus 8 is -3, not 0. So both of these work. Okay, I got one more for you. We're not done here just yet. One more. Okay. 5 over x plus 7 over 4 equals -9 over x. Okay. Whew. Okay, so what can we do cross multiplication here with the way this is currently written? No. Okay, we have 2 fractions here. 2 fractions. Don't worry, I'll take care of them. Thank you, guys. Oh, he took care of himself. Never mind. We got 2 fractions here, okay? So we need to get them together as 1 fraction so that we can then cross multiply, right? We cannot cross multiply with 2 fractions like this. So to add these 2 fractions together to a single fraction, we need a common denominator. So what is this fraction? What is its denominator missing? A 4. So we'll multiply by 4 over 4. What's this fraction's denominator missing? An x. So I'll multiply by x over x. Okay? So we end up with 20 over 4x plus 7x over 4x, and that's equal to -9 over x. Okay? Add them together. So we'll have 20 plus 7x over 4x equals -9 over x. Okay? And now we will cross multiply because we have fraction equal to a fraction. So multiply the x, we get 20x plus 7x squared, and then 4x times -9 is -36x. Okay, it's quadratic again, So what do I need to make it equal to? 0. So I'm going to add 36x to both sides here. Okay, we'll get 0 there. I'm going to go ahead and put the 7x squared out front, and then 20 plus 36 is 56x. Now, we're going to factor this one too. Okay, we're going to factor this one too. What can we factor out of here? A 7 and an x. Yeah, it's just a GCF for this one because there's no c term there. So we'll have x plus 8 equals 0. 7x times x plus 8 equals 0. So 7x equals 0, so x is 0. X plus 8 equals 0, so x equals negative 8. Okay? But I need to check my answers, and guess what? One of them doesn't work. Okay? If I plug 0 back into my original equation here, I'm going to get 0 in the denominator. So in other words, 0 does not work. We've got to throw that answer out. Negative 8, though, that's okay. I can put negative 8 in for x there. I can put negative 8 in for x there. So that one's okay still. Okay? So throw out 0. The only answer is negative 8. Okay? There is a homework assignment posted in Google Classroom along with the link here. So homework, go to Google Classroom. Okay, it's posted there. There's a PDF picture of the problems that you're supposed to do. Okay? PDF scan. All right.